All right, so like we said, this is the discussion of Air Street Capital's State of the AI report for 2024. They do this all the time, and I think I have a slide coming up to go through a time frame. This is session 3 on this, and we are going to finish tonight, come hell or high water. Because I got other things to do in my life except prepare these slides. So just let me just recap real quickly here. So this is the goals of our review. We use the report slide, and we've done this once before, just kind of as food for discussion. We discuss an item, everybody's questions are welcomed, and everybody's opinion matters. I've skipped many, many slides. This is a 250 slide deck or something like that, and nobody wants to watch all of them. Okay. Any questions on that and why we did that? I don't think so. Okay, about this report. The report is broken up into these 5 sections. We did the research one, made it partway through the beginning of on week 1, and then on the industry section, that was last week, we got partway through, actually most of the way through on that. And there's a section on politics, which I'm not going to cover simply because it's too opinionated and too fluffy. Let me put it that way. There's also a section on safety, which is very, very useful, but we're just going to do light coverage. And then we'll finish up with the section they have on predictions, which was what they'll believe will happen in the 2024 and 2025 timeframe. Any questions on that? Okay. So let me get started, and we will, let me back up. So this is their report. This is from 2 guys at Air Street Capital, Nate Beniach, who has put this together for a long time, and with his partner, Alex Chalmers. So I believe they're mostly out of the UK, but I did see a New York address, so maybe Air Street Press has them on both continents. Okay, they did do this. Every year they've done this, and I won't go through this, but we'll see a list of predictions for 2024. And every year, what I really like about this thing is they actually look at it and say, what did we say last year, and how many did we get right, and how many did we get completely wrong, and things like that. And we'll finish tonight by going through the one for 2024. Okay? Okay. And I'm just going to flip through a bunch of slides here to get us caught up here. Blah, 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 blah. And bear with me. Stop session 1 here. We're going to go look for the stop session 2. Okay. People, blah, blah, blah. We're getting close, I know. Oh, this was, I think, one of the ones we were talking about doing, but whatever. Okay, so we're going to now start with the new stuff on session, for this session. Okay, so one of the things that I thought was interesting, and they have some great titles in these slides, is Are Scientists Inventing Their AI Replacement? A question we always ask ourselves, being in the kind of the machine learning AI business. They're talking about this AI scientist end-to-end framework that does what every grad student hates to do, which is generate research ideas, implementation, and production of research papers. Now, will this replace your whole PhD study course? Maybe, I don't know. At least a master's level? Maybe, or something like that. And as you can see, you essentially give it a template, and it's, kind of, hey, I want to write a paper about AI and cars or something like that. And it brainstorms novel research direction, executes some experiments to verify those, and then writes them up. That just described my degree program to get my master's degree. This would have saved me 2.5 years of really hard work or something like that. And I know for my daughter, 6 years of PhD work, if somebody would have done this for us. So, I think this is a little pie in the sky these days, but it is something they will probably get to. And they have that little flow chart you can see over there on the left-hand column. It comes up with idea generation, and it has a novelty checker. So when you do research for your PhD, one of the first things you have to do is prove that it's novel. What you're doing is novel and you're somehow pushing science forward, blah, blah, blah. Sounds all good. Sounds like we're really important. And then I guess you throw in ideas and it says, how are these doing relative to those criteria? So I thought that was interesting. And even better, once you get the idea down in this column over here, you have to develop experiments for it. And this, as anybody who's done any experimentation, regardless of whether it's a degree program or not, can tell you is really, really where the rubber kind of meets the road. You spend a lot of time in this. So they have an experiment template. They generate code for you, of course, because as we know, our large language models are pretty decent at that now, getting better. And it even generates kind of a plan for your experiment you're going to do to prove whatever you're trying to prove in your defense or your dissertation or master's study or whatever you have. And then it generates all these templates. And get this, it even goes all the way down here to generate the text for your write-up, generates the manuscript, and then it has its own reviewing capability to see whether you properly closed all the things. You had like 5 things you were trying to prove. Did you prove those 5? And it'll go against known archives to see, whether you met the requirement. So this is an interesting thing. I mean, why do we need PhD students if I can just press this, right? So, any thoughts?
If I could push back on that a little bit, to me, it seems like it'd be more interesting to look at this not as PhD student replacement, but rather productivity boost for PhD students. Each one of these steps, novelty checker, you could do that. Presumably, you could have a model that helps you check for novelty much more quickly. Also, it doesn't scoring and archiving. It kind of where's the value on it? It's got to be not only novel, it also has to be useful, I would think. It is in some way good.
Yeah, my experience has been that scoring and archiving, that's when you try to get it through like, your committee or whatever. And maybe this thing needs to go and see what, who's got what budget for what. Okay. How it is in graduate school, right? You go through, and if your professor has a grant to do XYZ, guess what you're going to do? Some of your research on XYZ, right? Whether you know it or not.
Yeah.
But anyway, I get what you're going with that. Go ahead. I'm sorry, I interrupted you.
No, that was just kind of the end. It's not to rule out that eventually we have AI PhD students, but to me, it seems like a much more useful first step is let's focus on how do we improve productivity
right.
of PhD students so we can more quickly learn more things.
Right. Yeah, and obviously this is beyond just PhD. As you go into industry, if you're going to work at that level, you're going to end up doing this similar cycle over and over and over again too. Yeah. And probably in a much more compressed time frame and not as perfect, if you will, or academically perfect.
Right.
Ted, just to continue.
Yeah, a couple comments. So I heard one of the authors talking about this, and they kind of echoed your comments, Roger. They're like, hey, this is kind of like a proof of concept. We're not saying that this is, fully out there. But that maybe it really could help people. So like, as someone who just recently went through the trouble of writing up this system, they're like, for a lot of us, we don't enjoy the paper writing. So that 4th column on the right, maybe we can have it do like a lot of the first draft, second draft, and save us a bunch of time. But they commented that like it gets like really good at like tech and like doing figures and all that kind of stuff. So that can be like a tremendous time saver. one of the things they said that was the hardest for it is there is this novelty, um, trying to create novel research, and that it's not necessarily the greatest at like identifying, novel research paths. Um, uh, they also said that there was a comment that the current papers it writes have insufficient citations. There are citations there. They're proper, they're real, they're not hallucinated, but there's not nearly sufficient. So that's something that might require a whole nother model just to sort of, because, right, you see there's like 3 pages of citations in this paper. So there's like a lot that needs to go into that.
Yeah.
And then just like a final side comment for me, we're really running into a problem, I think, that with the volume of papers coming out, there isn't there isn't enough human bandwidth to review them all properly. So I don't think you get rid of the humans and you just go to an AI reviewer, but maybe you can reduce the amount of work by some factor, cut it in half, cut it in a third, if you can have some level of AI reviewing, you know?
Right.
I'll stop there.
Hey,
Well,
Ted,
I
on
think
the novelty checker part, you said that wasn't doing really well. Is that, I guess I read into that. I was just thinking that you're just checking kind of what's
The the
research that's been conducted that might be related, and do I overlap with it? Is novelty something more than that?
Yeah, so there's the easy part, which is just has this already been published? But the hard part is this an interesting direction? So
Okay.
I don't know how to explain it, but I'll give you a terrible example. If somebody said, "Oh, we have GPT," and if somebody's just like, "Oh, well, what if you just added two to every weight? What would happen?" Like that has not been done, but that's not an interesting direction.
Yeah. Okay. Yeah. Yeah.
okay. Janeth, so you have
Yeah,
your hand up.
just sort of continuing on that thought, right? So I was wondering, like, if it's a productivity gain, is it like you get a PhD in like a year, 2 years versus 6 years? Is it like also in terms of like, like sorry, you had to do a qualifying exam, you had to do a general exam, this, that, and the other. Is
I
that
guess
even
the
necessary
reason you
anymore?
I guess the reason
And
you do like a qualifying exam. So for UCLA, we do premium, which tests your knowledge of like how much you know about this subject. And then you have a qualify that's proposing your like you prepare a proposal, talking about your ideas to committee members and let them say that, hey, does this sound or not? How much novelty? Has anyone done this before? So that's kind of like the thing. Yeah.
Shulin, so
yeah,
you're
so
are you in this space now?
I'm preparing for defense actually next month.
Oh,
Yeah.
okay.
It is
Okay,
stress
so you're
actually.
probably more involved in this than any of us are right now. Or more
Yeah.
focused on it, I should say, maybe.
yeah, and
I
one other thought was like if if this LLM system comes out with, papers or dissertations or thesis or whatever, so you can also automate the other side of it, which is the evaluating of it. You could
Mhm.
also like then say, even if you have a human evaluating it, it would be like before you would get, with 100 different students, you would get 100 different um, varieties of
Mhm.
dissertations. But if it is all through an LLM or LLM system, this sort of is going to be sort of a uniformity or templating that might make it easier, or I don't know what the word is, to kind of uh, validate the thesis that is put forth. And it seems like there's a whole lot of implications potentially.
Yeah. Yeah.
So what
Well,
I would think is that first so basically my understanding of LLM is that it's kind of like learning the patterns, or say that it's kind of like giving a generalization of the given trend. So I would say that with this kind of like generative steps, you will generate the ideas kind of like what the past, it's kind of like doing a summary of like what has been done in the past can be done, kind of like it's kind of like a summary of the already created methods. So it would be useful. I think it would be very useful for engineering, because engineering is kind of like applying those previously used methods. However, for research, we have like I think we are sometimes kind of like the more valuable research is probably something that kind of like we create new methods, we create new models for the things, or it's kind of like discovering something new. I don't think that's something AI is, or basically the LLM model is good about. I don't know if that's
Yeah.
reasonable or not.
Yeah.
It's how to teach AI to think.
Yeah, I think that's where the authors were saying that they pushed it. That's why they have an entirely separate module just for novelty. They pushed it to really do what you were saying, to not just like mix and match, existing methods in a new recipe, but to really try to do something new. And if you look at the paper, I mean, they exclusively did ML research. They said that there are like remotely controlled biolabs and chemistry labs and whatever, but it just would have been a lot of work. So they strictly stuck to things that were code for this paper. And there are some actual pretty cool looking papers that this AI wrote up that I would say they're not bad in the sense of like just kind of some kind of regurgitating shuffling of old things. They really are new. But like if you said that like Mamba and those is like completely different from anything that anybody else has done before, right? This thing, that's what they're saying was weak on novelty. It's not going to invent state space models,
Yeah.
but it is going to try like a different approach for, transformers that maybe nobody thought of,
I think like I think that's it could be the limitation of LLM, because it cannot create something that like nobody has created before. And another thing is that does it make sense for the idea they generated? Yeah, that's my concern.
Yeah. All right, I'm going to move us along, or else we're not going to get through this. If that's okay, we can, guys. I know Julian you have something you'd like to say on that, but I'm going to skip you just for now, if you don't mind. Julius. Okay. Let's see here. We now go into this other area they were talking about where the systems are now creating their own data and things like that. And the analogy that when I read through this, they talked at see and do. The video inputs and things, this is for a car model, obviously. So it's generating this model or this application or whatever it is. I guess they call it a VLA, Vision Language Action Model. Is generating the real-time driving commentary, controlling the car, linking and making decisions all at the same time. So I don't know if it's just sort of like, the road would continue this way and we'll just continue on this scenario. But this actually kind of sounds sort of like what Tesla does with theirs. Tesla doesn't, it's pure vision. And this is pure vision, which is kind of interesting. If you see here, they have just video input going into their model. And they have some learn queries that they're trying to do, like, go around the corner, figure out how to go around these park guys and things like that, and text. And then how does the language action model, in other words, how does it do what it's supposed to do? So I thought that was kind of an interesting thing. And maybe Tesla for once was right on something. I don't know. Just my 2 cents on it. But it looks like an interesting way to go. And, I don't know whether like on the, would Lockheed on a fighter system do this? Probably not. Maybe in a car they can do it. I don't know. Interesting. So I thought we'd visit that one. Move us along. Oh, and here it is. Here it is. What is it doing? Oh, that's just their test data. Oh, and it's figuring out what to do, I guess. And then it goes. Okay, moving along. One other thing that they pointed out is robotics is back in fashion. And I thought this was interesting. I didn't know this happened. OpenAI disbands its robotic research team in 2021. I guess where they were looking. Now, is this thing flipping anybody off here? They got the thing with I don't know, the Rubik's Cube. I don't think it is. I think that's just an strangely extended finger there in the robotic arm. And then 2024, what are they doing? They're rebooting it again. So, OpenAI probably got a lot more money and they said, hey, that project, or maybe not, I don't know. I don't know what you guys think, but robotics is coming back in fashion again, using LLMs and VLMs versus the old, state-based models and things like that we were using before, which I think is kind of interesting. I don't understand how that works. If anybody does, please chime in.
Hey, Jerry.
Yeah.
On this one, this idea that it's coming back into fashion, is that with respect to simply OpenAI? Or is there a broader market trend? Did they mention anything about that?
There are probably other slides, Roger, that I skipped.
Okay.
I may go into that in more detail, so I don't feel qualified to answer that one. I'm sorry.
Yeah, there was more on the next slide. I don't know if you included 74, but there's other companies.
Okay, let me see if I got it on the next one. Was this 74?
Because I guess I didn't have the sense that we'd given up on it. OpenAI had, but the market in general, there's plenty of people still working on it.
Yeah, I know Google is and still does. And that's what this refers to down here. The VLMs they're using for understanding how to create the instructions and things like that. And this is the big one, I think. This helps it scale up deployment quickly for previously unseen environments. The faster you can test, the faster you can break, the faster you can fix, right? That's kind of the Silicon Valley mantra, right? Move fast and break a lot of things, fix them and build things and move on, So that's very much, Silicon Valley type development environment, things like that.
Yeah.
And Google, I know, with the Gemini 1.5 multimodal capabilities, one of the things this is actually, I believe, at a Google lab or something like that. No, that might be mobilities, but Google has a lab that looks similar where they have robotics running around, and I know they wanted to use some of these VLMs to increase their productivity, to be able to decrease cycle time, I guess is probably the best way to say it, to break things fast and fix them and move on. And this is an interesting, I think I talked about this on the Google I/O thing that they had, and Dev corrected me, the 1 million, not 1 billion parameter long capability. They're now at 2 billion and are looking at going at 5, I believe, by the beginning of next year. And I believe part of that has to the context window size, is to do with these other projects that they want. They can't, there's language requires, 5 million tokens seems like a lot, but for some of these other things, it doesn't really, it isn't long enough. So, okay.
So just a quick question there. So I'm guessing that there's some watering down, even though the context window might be 2 million. If you use a 2 million token prompt versus a 1,000 token prompt, I'm guessing that somehow the model's performance would be lower, even though it can handle that.
That's correct.
Is there any sort of results around that as to showing
if you search the I believe the name of the benchmark is the needle in the haystack test. It was a few months back that there were a bunch of people were kind of running it. Claude does unusually well, but all of them kind of suck, basically. Interestingly, quantization makes them way worse.
I see.
So they don't do any worse on evals, but that's because the evals are tightly questioned. They generally aren't long context evals, so you wouldn't have noticed until now.
I
Yeah.
see. I see. Thanks.
Not surprised that quantization has a very negative effect when you essentially take away your ability to see fine detail. You know, the errors probably pile up as you go down the road.
Turns out if you take away precision, then you take away precision.
Yeah, and you kind of drive off the side of the road if you're a robot.
Right.
Yeah, I don't need to correct. Oh crap!
But I mean, like, think about it. If you quantize to 8 bits and you have a length 2 million context, what's the difference between the cosine of like 1,900,000 and 1,950,000? You know,
I wonder if it's kind of this piling up of small errors or things like that over time.
Well, that's one kind of issue that'll definitely like show up in any benchmark. But I'm saying specifically this long context or needle in the haystack, right? Like you don't want to be 50,000 tokens off when you're doing needle in the haystack. But if you think about like once you've divided 2 pi, right, by like, I don't know, 7 million, what's the difference in value when you are 50,000 tokens off? So for more recent tokens, it's a lot easier. But
so there was a paper, transformers need glasses or something like that, that dove into some of these issues. They kind of looked into when you have a long sequence, how can you differentiate it? How does quantization affect that? So if we're interested, that might be a paper for us.
Yeah, I'm also worried. This is getting into the weeds. I don't know if there's different implementations of needle in the haystack, but the one that I've seen, it just has the same nonsense repeated over and over again, wherever the secret message isn't. And I think it would be a much more challenging problem if you had like random tokens instead of just like Apple Bob Charlie Fox tree, Apple Bob Charlie Fox tree, Apple Bob, you know what I mean? I don't know exactly what the sequence is, but it's longer than that. But it's still just, you know, doing the same things over and over and over again. So if you're allowed to fine tune on that, like instead of like really finding the needle, you can just learn to ignore Apple and ignore Bob and ignore, you know what I'm saying? So
I believe the one that I found was if you replace you give it a whole book and then you replace like you make one of the sentences like not make sense it was something about like Shakespeare and pizza, but I don't remember the exact thing. But they replaced like something that was like normal, they put something in out of context, and then they tried to see if the LLM could. I believe actually they just said like what's wrong with this book or which one is out of place. That was the one that I found particularly impressive. Yeah,
that sounds to me like a much more accurate benchmark as opposed to the one I was saying. The one I was saying though does have the nice property that it's like it's verifiable. Did you run the benchmark exactly the way you were supposed to? And when people have different models and different architectures and different context lengths, it's very easy to define what the right way to run it is. But I like yours better.
Okay. All right, I'm going to move us along.
Go for it, Jim.
Okay. Let's see here. However, the Hugging Face as building all these tools and things like that to help out with the robotics. So that I kind of thought was interesting. It's not, you know, they have something called Lay Robot. Took them a long time to come up with that one. And they, it's a gripping arm, and I guess they're controlling of the robotics. So that way, so now that it interfaces well with a large language model, because typically robotics have not interfaced well with them and things like that. So interesting.
So what is this? Is this like open source 3D printed robot? Is that what I'm looking at?
I don't know if I think it's doing tasks here. I'm not quite sure what this one's doing here on the left, but in the center, it looks like it's trying to put things back into where it's supposed to be, if that's what I'm seeing.
Well, I'm looking at the text edit. High performance robotic arm for $115.
Yeah.
It looks interesting.
So maybe it is printing then. That's a lot cheaper if you remember the days when everybody was at Sully's house trying to make a robotic car go around the thing. And remember, his old office had that very expensive printer. I think he had a 3D printer in there. Oh, 1/3 the cost, 2 times capability. How's anyone's French? Can you translate the third one?
It is a library of open source code developed by Hugging Face, which makes the robotics more accessible to everyone with pre-trained models. The library is the best I can do, I think.
Yeah, because Bibliotecs is the library, right?
Yeah.
Yeah. Oh, it's probably in the show more part that nobody clicked the button on there.
Presumably, yeah.
Yeah. Okay. Yeah, my French sucks. But anyway, it's good to see that robotics is coming into there, and Hugging Face and other people, I guess. I don't even remember how many other slides I might have skipped on this, but there were some other slides having to do with the robot stuff. So that is a big thing. Let's see if there's another one after this. Yeah, okay. And this was actually creating what they called a VLA, or Vision Language Action Model here. The CMU team, they came up with this like don't do this type thing when they're ordering their robots around. Based on what the human thought, and that was a way to kind of feed it back into the model and make it work better and not do dumb things like knock things over and things like that, or the robot not knock things over. And this is the one here that I like, the last one here. It said the enhanced models are trained to reason step by step about plans, subtasks, and visual features before deciding on actions. So that really comes down to, you're trained the model so that it says, hey, if you're going to hit this beaker or whatever, don't do that. Go back, rethink this thing, and do something different than that. And they kind of show this here, this chain of thought type thing. I can't read it because I have pictures up on my screen, but let me move over a little bit here. Okay. You can kind of, the end goal is to clean the sink, and you can kind of see this chain of thought one is smarter about it. It actually lays out the things rather than just visually saying, oh, move it to some sort of delta X, delta theta, and delta the grip, open it, close it type thing, pick it up and drop it, which is kind of, I gather, how current systems work. This actually gives you object bounding and the position, and then it has this task definition, like pick up a carrot. That's how we think of it, right? When we think of something like doing this, we think of it as a task. We don't think I'm going to move over 0.5 meters this way, drop my hand down, 20 centimeters or something like that, expand my fingers, reach the carrot, and close my fingers on the carrot, right? We think in terms of tasks. So I think this is kind of interesting how they're doing that and then translating that out. I'm not a robotics guy, but that's my 2 cents. Okay. Yeah, this is this enhanced trained to reason step by step in visual features before deciding on an action.
Are they talking about, in this case, RT2?
I don't know what it is. Julius, I see this Stanford logo on here. You wouldn't happen to know anything about this, would you?
No, sorry. I've been around robotics since Benford at the AI lab, but I've always been in another area. I do get involved with the low-level signal processing, though.
Okay. Sorry, didn't know if you had more insight than this paper has on how this all works. But okay. Anyway, moving along. Okay. So one of the big things, as it says in the first line there, is medical imaging data sets are really difficult to come by, and even worse, having worked at like Novartis and a few other large biopharma companies, there's a lot of money involved in that, and this licensing, even to a large company like a Novartis, can be prohibitively expensive. Like you're going up to a VP to get signature to buy a subscription to data sets and things like that. So if we can synthetically do this, it would be much better, much cheaper, and researchers wouldn't be filling out, the third request to get access to something. It's very much a, fee for data type business. So, yeah, so you could see here, realistic image generators have flooded the internet, and, of course, our vision generation models. And these could be repurposed to regenerate realistic medical images to use in model training versus having to go out and license those data sets to do your research. They're showing, chest x-rays, I guess, and things like that to see if you have lung cancer and what have you not. Let's see, I think. Does it tell what they are?
So, Jerry, do you know, is the primary thing here to get around some sort of like privacy or licensing?
Two things.
I understood how using synthetic data for training a model is any better than the original model that generated the synthetic. The only thing I can see is that, okay, the synthetic data maybe has a lower noise level. Like, the original raw data had a lot of noise. In training a generative model, you were able to kind of smooth out that noise. And so now you have a data set that's cleaner. I can get that. But I'm not sure what it is, what their objective here is for using.
Well, there is, in that first sentence where it says licensed to research or commercial products, that is a barrier to actually doing good research in this area. Because to get a person's x-ray, there's a whole bunch of hoops you have to go through and things like that. And then to get that x-ray and you use it like these chest x-rays are showing, to use it in a way for research where a lot of researchers, not just the individual's doctors, are going to look at that. That's another barrier and things like that.
So families that could anonymize the data.
Anonymize or I guess anonymize is a good term for it, but it's synthetic, right? So it's real close to the real thing, but it's synthetic, so it's not owned and it's not subject to HIPAA laws and all these laws and things like that kind of get in the way.
Yeah, but presumably the generative model had to be trained on these original expensive high quality medical imaging data sets.
To some degree, I suppose so. That's true.
Yeah,
that is an interesting. I see your conundrum that you're bringing up there. At some point, though, and they get into this more in this section we'll go through. The synthetic data can be more useful in some cases because I won't call it perfect, but it's more focused on what you want to get done. Does that make sense?
Yeah, I mean, it seems like it had to extract something, the patterns from the original data set to train the generative model. So it can't be.
I think this is, maybe improving the model over time too.
So,
in addition to just
mutual classification. If I can jump in here,
please.
There was a comment in the chat, and so I also agree. I think it's a really good question, Roger. So I think there's two possibilities. One is that, let's say you've got like congestive heart failure and you've got pneumonia and you've got other things. You're still only, like, as you're pointing out, you're really still limited by the number of heart failure training samples you had for that generative model. However, they do all sort of share like the ribs and the lungs and the whatever. So like all the ones that are about pneumonia get to benefit from all the healthy heart pictures from all the other x-rays. Whereas if you only train on pneumonia images, you not only get that many pneumonia lungs, you only get that many hearts. You see what I'm saying? So there is some joint things that you could potentially leverage by pooling together all of those things and having this model sort of connect the dots that, like, I can't use a CHF heart when I'm supposed to be doing a pneumonia image, but whatever. So that's like one possibility that I can see. And then the other thing I'm not quite sure is maybe ever so slightly they're benefiting from the CLIP model, the same way that those robotic things were benefiting from LLMs. There's a certain amount of very basic world knowledge that you get to lean on from CLIP without having to have X-rays to learn those things.
I was also thinking that maybe this is sort of an extension of the data augmentation. You do data augmentation with like rotation, translation, this, that, and the other, clipping. So you also have LLMs augmenting your data with the existing data set in some way.
Yeah, I mean, I'm not a real big fan of synthetic data, so I really think this is a good question. For me, augmentations I use for avoidance of overfitting, not really to increase the ceiling.
Yeah.
I see the point.
In one of the talk, I was listening to a person who's basically training AI model using the synthetic data in radiology, and he did point out that evaluation of the synthetic data is very crucial because many cases the model hallucinate there as well. They generated data where the heart were in a different place, the lungs were in different places. So he kind of cracked a very funny joke also, I don't remember. But yeah, these are not like a gold copy kind of thing that you normally get from the real world data. So should be taken with a grain of salt.
Yep. Although if you look at the second or the first bullet, I guess, the real black one, it says it's possible to generate synthetic CXR scans with high fidelity conceptual correction as evaluated by board certified radiologists. So they are saying they are generating some fairly high quality data there. So that's kind of an interesting thing.
That's the point of the slide, is that they were saying they're able to, and it is a little bit of a head scratcher because of what Roger's saying. Like, well, then you could have just trained the other thing on those images instead of training a generative model.
Yeah, interesting. Oh, well, I'm going to move on then. We'll have to let that point lie. Okay. We're moving now out of kind of an application into this industry section, this third thing, and we're going to kind of go through this fairly quickly here. Hey, guess what? NVIDIA is powerful. We all knew that, right? And I think Jensen must have like 5 million of these jackets, right? He's got one in every color. They're all leather and whatever, guy has his uniform and that's part of his uniform. 3 trillion, wow, like that. And you guys probably already saw that on the S&P, is it the S&P 500, the one that dropped Intel and replaced it with NVIDIA? So that was kind of interesting. So hats off to them. They are very, very powerful.
It was the Dow, I think.
Dow, thank you. Okay.
Yeah, Dow 30, which is like a really exclusive index.
Yeah. The big boy, real big boy, big company club,
Is this a good time to mention that I may or may not be sort of going into tech sales to sell some GPUs at this point? So if you happen to know anybody, feel free to send them my way.
Oh, okay. Well, if you have a few samples you just want to drop off, I'm sure the rest.
Just free sample? Absolutely.
Yeah. This one didn't work in a show or something. Let's just send it to Jerry. Maybe he can do something with it.
Yeah, there's a scratch on this H100. Maybe Jerry could.
Yeah. Oh, darn it, scratched another one. We have to send him 2. Damn. So if you want to do that, are you going to get the leather jacket though?
Oh, good question. Actually, I should play hardball on that.
Yeah, you get the Jensen leather jacket too, man. Okay, well, that's good. That's good. It's good to know people in good places. All right. However, the established competitors haven't kept up. Duh. I wonder if that number's lower now, and the EPS maybe even further negative this year than it is there. They're kind of in deep doo-doo. And NVIDIA's up. My NVIDIA shares are up. Thank you, Jensen Company. I appreciate that. I should have bought you years ago, but you kept going up and down, so you scared me. But it looks like they've got a lead. Maybe somebody will catch them. They say NVIDIA's position seems unassailable. Over what time frame that comment is made, I don't know. Let's see. Buying NVIDIA stock would have been far better than investing in its startups, these various startups, things like that. Yeah, okay. Thanks for reminding me that I zigged when I should have zagged. But this is amazing here. At 120 billion, they're a 20x return, and I believe return.
Wild.
Yeah, and I think that's over about what, 3.5 year time frame or something like that. That's some serious money that they're returning. So, 6 billion becomes 120 billion. Boop.
Yeah, I'm used to those, and I'm used to those kind of numbers in crypto, but they're usually millions and not billions, and so it's weird to see that on the
yeah. But the crypto goes the other way just as fast sometimes.
Oh yeah,
as it goes
absolutely.
Up.
I don't watch them because I will just give myself anxiety nonstop.
Yeah, you'll be eating Tums or something like that, if you have any money invested in that. But anyway, NVIDIA's had a good run, and they had some other slides in here on that. But nobody believes that the line can go up and up forever, or at least not everyone believes the line can only go up. And so there are some people here, that question about AI. Is AI, going to fall by the wayside and things like that? We'll see. And let's see. And then, of course, the bigger companies, don't want to be beholden to NVIDIA anymore. Google has their TPUs. Meta has their in-house. I happen to know some guys working on some of their in-house AI acceleration. There's not much information out there on it, but they are looking at the same reason that Google does, is because they don't want to be beholden to some entity outside of themselves that they don't control. They want to be able to decide, we want to go this direction with it, not where this generalized producer is going, because they have their own specific needs, things like that. Here's an interesting one. I thought this last one. OpenAI has been hiring from Google's TPU team and is in talks with Broadcom to develop a new AI chip. So who knows? There's more competition coming, things like that. Google's big thing, though, is in this thing here is the energy efficiency, because the Google TPUs primarily reside in the Google Cloud in their data centers. So that's their electric bill, essentially, right? Or keeping the electricity flowing. So the thing they want to do is reduce their compute cost, their electrical costs in those centers, and then still maintain their high charges to their end customers, so the profit margin increases. Makes perfect sense. If you can make it cheaper, you can sell it for the same, you make more money.
So I have a question.
Yep.
So these guys and all of the competitors that you're talking about are I think, still modeled around this idea of doing, more tensor operations per second type of thing. There's also this question of, do we have we have a transformer architecture that's very tensor intensive. But are there other architectures that will be different, that don't rely on the tensor math as heavily? And my understanding is that language models are extremely sparse tensors as well. So I'm wondering, is NVIDIA looking at those types of transitions, or are they just trying to build bigger, faster tensor engines? Has anybody heard of them kind of hedging their bet in other directions?
I don't have any information one way or the other.
I don't have any information on it. But that very first slide that said, NVIDIA is king, right? It said there's like 3 things that could kill it. And so one of them was like a change in research direction. So away from what you're talking about, lots of tensor matrix multiply. So that change doesn't mean, so-and-so anticipated this and will be ready for it, but it would completely level the playing field. Everyone would be starting from scratch.
Right.
Well, at least it's possible somebody would actually see it first and get a head start, but minimally everyone would get an equal start for if it's suddenly like, like the papers, like we can do integer addition and we don't really need matrix multiply anymore.
Right. Well, but to have a big impact quickly, you have to have scale. And so that's why I was kind of wondering if NVIDIA is hedging their bet at all in any direction. I could see them being toppled quickly. Like you said, if the playing field's leveled, and this is 10x more energy efficient, everybody gets started over again. But NVIDIA, if they could lead that, they already have the at scale part of it solved.
Yeah, I mean, it seems to me that they definitely, every generation, they throw in a lot of additional stuff, which just in case it pans out, becomes really big, But I think the kind of stuff we're talking about would be such a fundamental change that just because you allocated a few transistors to, addition units, it really isn't preparing you for, nobody cares about your tensors anymore.
Right. Yeah.
Historically, the CUDA barrier has been really big. People have really grown into that API to the point where, you just can't get there with Metal very often or other competitors. They're trying to, close the gap at Onyx. But the CUDA barrier has really been big. So if the new breakthrough, you either got to support CUDA or not need CUDA. It's a big barrier.
Yeah.
Yeah. So the CUDA barrier is maybe 40% or something like that. So what we're really talking about is like if there's a completely different paradigm that's Rogers threw out 10x, right? Then that blows past the CUDA barrier.
Like ternary arithmetic, like plus minus 1 0, nothing else.
Yeah. Well, there was one paper we did that talked essentially on that, right? Those guys at UC Santa Cruz, was it, I think, or something like that, where they had done something like that. So, okay, so
I'm sorry. Maybe this is too much of a question if we're running late, but I was wondering, Julius, can you explain in a couple sentences why the CUDA barrier is such a big deal. To me, it seems like transformers have tensor multiplies. There's not a lot of variety in the operations.
Yeah,
so why is that important?
Well, I don't have a lot of experience with this, but here's my experience. I download a lot of stuff on GitHub and try to run it, and I don't have a GPU. I have a MacBook Pro, and I don't really want to. If I need a GPU, I'll go to the cloud or I'll use one at school, that sort of thing. So my experience is I will try to use if CUDA is available, I'll use it. And then if it's not, I'll try to use MPS Metal, the metal layer at Apple. And if I can't do that, I'll try the CPU. And again and again and again, there's a missing primitive in metal. So it's usually something like the discrete cosine transform or something like that. It's just some fancy function that's used in the adversarial loss, which is more conventional signal processing kinds of stuff. And it's just not implemented. So I do, go on the issue page for metal and I log every single one that I hit. And most recently, I did get through. I punched through on an implementation of what's it called, the spectrogram, the audio spectrogram transformer. That thing just worked. It's a variation of vision transformer. So maybe we're getting there. But that took a long time, a very, very long time. So it's just all the things that people have grown into in CUDA. It's a very large API, very large library, and you just don't have that in some lean, mean thing that's just going to implement your inference transformer. That's so for production, you're probably fine. You can probably use AMD, and they've got all the software you need. But if you're a researcher and you want to run everything that you can get your hands on, and it's you just trip over it. In my personal experience, 80% of the time I trip and can't go because.
Okay. So I see it where you're using it for research, you're using it for different STEM types of projects, etc. But when you're talking about large language models at scale, that's where I'm just not quite. I don't quite understand why CUDA gives a big advantage because.
Yeah, that's a great question for Ted, from that AWS presentation. So that's
no, this is very different. So if you have just like some sort of query and key multiply, and you have, batch by token sequence length by whatever, and you have these 3-4 dimensional tensors. Okay. So you've got your input, you multiply that by matrices to get your queries and keys, and then you multiply those two together. If you just figure out, let's say they're 4-dimensional, like the number of permutations for which of those 4 dimensions is physically first is rows, and which one of those dimensions is second, and which is third, and which is fourth, and how that impacts your ability to do the matrix multiplies. Combinatorially, it's like it explodes in terms of the number of different possible row dimension orderings. And if the CUDA compiler does it better than the ROCm compiler, then it doesn't matter what your bare metal hardware can do for matrix multiplies. CUDA is going to beat you by like 30% for the same hardware just because it told the GPU to do the operations in a smarter order. So that's the CUDA barrier that I talk about, where AMD, if they're 25% faster, when you run your code on it, it will be slower than CUDA, even if the AMD hardware is 25% faster.
That's like the iOS versus Android issue. Even for the same hardware, the scheduler is so much more efficient for audio that you get like a 3x headroom because of the scheduling. So it's all in the software. They've had many more years to optimize it.
Who's more efficient? iOS?
iOS, yeah, you can run up to like 75% of the CPU and not run out of real time. And at Google I/O, they actually documented that you should not ask for more than 25% of the CPU. That was a few years back, so I don't know if that's current at all. But back when I last looked at it, which was at least 3 years ago, that was the situation. So, for the same hardware, you get a 3x difference. Huge.
Well, Apple seems to be kicking butt with their latest architecture. So
it's the same answer. You know, they had so many more years to optimize it. They were optimizing for audio. I mean, I was there when they punched a hole in the Windows server, which was PostScript, in order to put QuickTime, you know, in a bitmap. And so, you know, this optimization has, you know, had years. And there was like a huge, like 40 people in the OS group who were beating Unix into Berkeley 4.2 Unix into submission for real-time support in NextStep. Yeah. That was the starting point for NextStep. Yeah.
I remember those guys.
Yeah. So that was a lot of OS guys. Avi Tavanian was the head of the OS group, and he went on to Apple. And so all that came over with him. Really good stuff. I'm going to turn on my light.
All right. I'm going to move on. And we are not going to, don't worry about next week. We're going to go next week. I just opened my other window. I opened this up and we have a number of slides. I apologize for taking so long to get through this, but I think it's always been it's a good discussion.
Well, it should be able to go as long as it takes before they become obsolete, right? As long as these are still.
That is the fundamental.
Yeah, by the time we get there, they'll have actually come true. So
yeah, so we have about a year until the next report.
Yeah. Right. And by then, Warren will be dropping, GPU samples into the mail to each of us by then, right, man?
No, the GPUs will just be walking up to you, you know.
Yeah. Don't forget me. Don't forget me, man.
Oh, I got you.
All right, buddy. Okay, let's see here. OpenAI is hiring Google's 2PU team. And talks about broadcast. So, we're not the only ones, I guess, that have questions. And these guys are essentially, I assume they're just spending too much money with NVIDIA. It's starting to affect their bottom line. Obviously, Google, that was, the reason they did it, Meta, and then OpenAI is probably doing it too. Sam Altman is talking to government UAE. They got to do something with those petrodollars, so now they're going to maybe build chips. So who knows?
AWS is also doing it with their for inferentia, Trainium, something. So they have their own silicon as well. And
really?
And when we looked at it, it was the same thing with the CUDA barrier. Like if you had to run our software, we had to go through a transformation phase and
versus just turn the switch and go, right? Yeah.
Right. Exactly. And so there's too many questions to go. Yeah.
Mm-hmm. Yeah. It seems a bit risky. Well, I won't say risky, but maybe that it is risky and potentially expensive, right? It could be a deep hole. So.
Yep.
Yeah, I can see that. Makes sense. Okay. Let's just go through this. I'm going to go finish this section and then we're going to stop for the night. So the question is, of course, in all this, and that's appropriate to our talk, are we making money? In Gen AI and things like that. We're hearing a lot of a lot of the buzz and things like that. And all these companies are, pumping in money and things like that. But where is the big revenue, right? Investors are confident that it's going to happen, but when? That's always their question. If we all know that Sully isn't here because he had to go, he's out doing his money thing, right? That he has to do on that, such as the life of a CEO of a startup, or a smaller, not startup anymore, but, a smaller company and things like that. And so these companies are in the same sort of deal where they're out looking for investors to move these things along. And investors really have never done this AI thing. They've done a lot of tech, even like the Andreessens and things like that have done a lot of tech, but this one's just a little bit different because of its effects. So I think they're a little, on the fence about it. Well, I don't think they're on fence about it, but they're not quite sure how to handle it. Go ahead.
What was that chart? What's the 15?
Let's see here. But it started. Is this revenue? No.
It's something times something. I just don't know what it is.
Yeah.
I think the valuation is that much multiple.
Oh, is this what this
of
I see.
Revenue, which is
okay.
Just insane.
Yeah, 500, almost 600 times your revenue is your company's valuation, and for whatever character and that could be one of two things: either they don't have much revenue, or and their valuation is low too. There's nothing here that says in dollars. You know what I mean? There's nothing on this chart that's in dollars. It's a ratioed sort of thing.
Well, like Sam Altman wants how many $1 trillion, and I can't remember, but like if you compare that to like the entire GDP of the US, Europe, whatever, it's like how is one company going to ever be able to pay back investors if the entire world economy isn't if the world gave all their money to OpenAI and that's still not enough to pay back your investors, then there's something wrong with that model.
Yeah, they didn't give you enough money. It's their fault.
Okay. It's interesting that this chart does not at all give you an idea on that, right? This is just a ratio type thing. So, but that's a good point. They're saying they need all this money to get to the next thing. It's starting to sound like I don't know, like the DoD. The DoD always has these. I worked DoD programs, and there was always this like, well, we need this, and we're begging for this money and this and that and whatever. That's in the past. The days of working with Lockheed and those companies. So, anyway, it is, and there's a lot of money to be made. Investors are confident, but at some point, there's got to be when are we going to be profitable? Where's the money? That has got to come. And I suspect that's going to come hard and fast when, nobody wants to be the first one to ask the question, the real tough question, but when it does, it becomes hard and fast. Well, this is kind of where this slide is leading into here. OpenAI could lose $5 billion this year is what somebody's saying on their thing. Anthropic gross margins flag long-term AI profit questions. We all should know about that. We're not surprised by it, but maybe people are starting to ask the questions about, we're throwing a lot of money at this thing. When is the return? Okay. This is more consumerish. OpenAI's O1 had this particular premium on its price because it was doing so well. I've never paid for tokens on it, so I don't know. But you can see over here on the price on the far right, it is by far overshadowing, some fairly decent models here. The Google ones are cheap because Google has a closed ecosystem. They can kind of play this. They're playing both ends of the game, and they can underbid a number of people. So maybe they shouldn't be included. But Claude, Mistral, things like that, and OpenAI is out there in the price. Okay, it's inference all the way down. Remember the turtles thing? It's inference all the way down. Models get cheaper though. GPT-4 is now 100x, did a 100x drop to go to the mini version. And with Claude, they did a 60x over at the people at Anthropic. So things are getting cheaper, but is it good enough? I guess. I've never used Claude, so I don't have an opinion. I do have used GPT-4 mini, and it's pretty good if you got a small system that you want to put in there. It does a good job.
Yeah, I was going to ask that question. When you're talking about a drop, does that assume that the quality remains the same? If you're comparing apples and apples, is GPT-4 the same quality as GPT-4?
GPT-4o is actually better quality, I believe, than GPT-4.
But is the mini? better
The mini
quality?
one, the mini one is restricted down to certain problems. So, context length is limited, things like that, right? So
Yeah,
So
so
what
maybe it's not really 100x if you just go to 4.0 instead of 4.0 mini, Roger. But I would say that pretty much everybody agrees that 4.0 performance quality is roughly comparable to GPT-4.
yeah.
Okay.
Vibes wise, it's like slightly worse, kind of at a couple of things. It just feels like it's like giving me the textbook answer a little bit more than GPT-4, but GPT-4 had the same problem as well, but all subjective.
And some might do a little better on a few things, and it does a little worse on some. But it's certainly in the ballpark. It's not, if it's not 100 times, if it's 30 times cheaper, it's still in the same ballpark of performance.
Yeah.
Okay.
There's been no like riots with protesters saying, "Give me back GPT-4."
And the high cost of GPT-4, if you all remember that when we first started using that. I'm like, oh.
And do we know? So do we know? Is that reduction in cost? Is that that could be a business thing, or that could be changing, underlying technologies, algorithms, whatever?
I mean, how did they achieve it?
Yeah.
How can they charge so much less?
Well, and is it are they able to charge less because somehow we've improved something? We do some sort of batching or
Yeah,
or whatever.
I don't know the answer to that one.
They did release the batching API recently, so that they might be doing that secretly on the back end for their front end people. I'm not sure.
Mm-hmm.
I mean, LLM serving is definitely a lot smarter now than it used to be. I don't know how much you can get from that 3x, 6x, maybe 10x. I think Warren, I can't remember if you were the one who shared on this, but the conventional wisdom is that GPT-4 Turbo is in some way distilled. It is smaller than GPT-4, and 4.0 is even smaller. So it costs them less to do inference for 4.0 than it did GPT-4.
Okay.
In combination with the improvements that are just across the board. They're not necessarily unique to OpenAI.
Yeah, and it looks like in the chat, it looks like they did miss out on the Claude 3.5s for this, which would be kind of interesting. But I think like 3.5s for me, at least Sonnet wise, has been mostly like those are the performant ones, and then the cheap ones are 4.0, or at least that's like how I treat them.
Okay. Let's see here. But Google has their own product offering, and they're following along the same curve. If you see here, they're going down. They have 1.4 launch, and then they have just gutted the price on it. And I think that is to compete. They've actually gutted the price to compete, to stay in the game. And then they have their lighter weight ones like Flash, and they've gutted the price way down on those too. This is something that, it's an 8 billion parameter model, so it's meant to run on something lighter weight. And I hear they're going to even go, cheaper on these other models, like the Gemini 1.5 or 1.5. I forgot what the new name is. They have a different name for it. It's still Gemini, but it's not Pro. It's something else. But they're going to come out, even more. I wouldn't be surprised to see them take another 50% off or something like that to 60% off. So it is getting cheaper. Right after I bought a GPU, of course, but hey, they're spent $2,000 on a GPU, but hey, that's the way it goes.
So does it feel like, Gemini is sort of a notch below GPT-4o and Claude 3.5 Sonnet or something, or does it feel like they're all sort of the same level?
Performance-wise, for me, it's Claude by a mile, but I'm gonna miss.
I think I know maybe one person that likes Gemini, but otherwise, pretty much, yeah, Claude and GPT-4 seem to be everybody's favorites.
4 or 4.0?
4.0.
Well,
4.0.
4.
The thing that I do like Gemini for actually is uh like if you're doing, or like I guess this is just sort of like a practical thing, but like if you're doing something like trying to check your email inbox or whatever, you just record your screen and then you dump it into 1.5 Flash, and it's basically free to like have it, you know, summarize all of your email inbox and tell you what matters, or like, you know, kind of keep track of what you were browsing and pull all the interesting papers out of it, or whatever.
And Notebook LM is pretty cool.
Yeah.
So
that's basically context size, is it? That's keeping, that's keeping the interest in Gemini.
Yeah, for me it's context size and price, and it like video understanding wise it does really well, and I think Anthropic, there isn't, I don't think there's a Claude that does video. I think he only does images, so you could feed him stills, but I like the the Gemini Flash being basically free, and I think actually free for a while on AI Studio is just like makes it pretty useful. You know, I wouldn't call it performant, but it's great for video use cases, I guess.
Okay, thanks. Yeah, sorry, Julius, I didn't mean to cut you off.
Yeah,
I'm fine.
When Pro first shipped, was in beta, I tried it out and was able to ship it. Several of my home movies from travels and things like that, and you know, and just query it about, well, where did we see this, or where did we see that, or what's the sequence? We were on a train. What's the sequence of signs that we saw going, in this part of Norway? And it got them accurately. It went through and ripped through it really quick and did it. I was really quite shocked that it could retrieve that information from it. So, it's a good system, but yeah, you're right. It's compared to some of these others. I think day-to-day and LLMs, it's a little laggy because they spend a lot of money on the multimodality of it. So,
for code, for math, I find Claude number 1, GPT 4.0 number 2, and Gemini number 3.
Okay, cool. All right. I think this is a good stopping point then for tonight, and we will have number 4 next week. These things always go a long time, and please, everybody, let's not trying to rush us through this or anything like that. Let's spend the time we take to know this, to know what's going on, where we're at, and where we're going, because it is what we do, right? So, okay. And with that,